Okay, so in this revision video, we're going to look at how you solve quadratics. We're going to look at every single question you could get asked in your higher GCSE paper, and we're going to discuss which methods to use and why. So this first question is just a basic factorise and solve question. However, I'm going to show you the method which will work for all quadratics. So first of all, we need to remember that a quadratic is written in the form ax squared plus bx plus c is equal to 0. And we need to work out two numbers which multiply to give us the product of ac. We know that a is just this number 1, c is negative 24, so we're timesing two numbers together to give this negative 24, and we're adding to make b. And in this case, b is equal to 5. So we're timesing to make negative 24, we're adding to make 5. So now I'm going to write down my factors of 24. So negative 8 times positive 3 gives you negative 24, negative 3 and positive 8. We could also have negative 6 and 4, negative 4 and 6. And we can keep listing these. However, you will notice that up at the top, negative 3 plus 8 gives you our positive 5. None of these other pairs would give you the answer 5. Once you've worked out which pair of numbers work, you can then write these in your brackets. So you would have the answer x minus 3, x plus 8 is equal to 0. Now we need to work out, as it's asked us to solve, our two values of x. The reason we have two solutions is because our quadratic would pass through our x-axis, where y is equal to 0 at 2 places. So this is why we're getting two solutions here. So we need to, first of all, make this bracket equal to 0. That gives me the solution x is equal to 3. And my second solution, we make the second bracket equal to 0, and that gives me my solution x is equal to negative 8. So if I wrote these solutions on my graph, you would have minus 8 and positive 3. And these are the two answers which the exam would be looking for. So question 2. There is a hint in this question, and this hint tells you what method to use. It looks like a normal quadratic, however, it asks for your answer correct to 2 decimal places. That means we're going to have to round our answer. The only way you're going to get an answer which comes to a certain amount of decimal places is if you use your quadratic formula. In your exam, you will have to remember this formula. And if you remember the general way of writing a quadratic, we have ax squared plus bx plus c is equal to 0. Looking at the way we write our quadratic, that would tell us that a is equal to 2, b is equal to 4, and c is equal to negative 5. So if we now substitute that into our formula, we would get negative 4 plus or minus 4 squared minus 4 times 2 times negative 5, and that's all over 2 times 2. The next step, I would start simplifying this without using a calculator to begin with. So we have plus or minus 16, negative 4 times 2 is negative 8, negative 8 times negative 5 is positive 40, and that's all over 2 times 2, which is 4. So now in my calculator I would type in minus 4 plus root 56 over 4, and that would get me my first solution of 0.87082. And then in my calculator I would type in minus 4 minus root 56 divided by 4, and that is equal to minus 2.8708. And then to finish off, we need to round these to 2 decimal places. So we would have the first answer being 0.87 and our second answer negative 2.87. Okay, so looking at question 3, it looks like a standard quadratic. However, it doesn't give you that hint that you've got to round it to 2 decimal places. That then means you will be able to factorise this into double brackets. You could, if you wanted to, use your quadratic formula. However, you'd need to be aware that actually this would most likely be in a non-calculator paper. So we're going to look at solving this by factorising. We again need to remember that the general way we write a quadratic is ax squared plus bx plus c. That tells me that a is 2, b is 5, and c is negative 3. We again start off by writing that we are multiplying to find the product of a, c, which in this case is negative 6, and we're adding to make our b value, which is 5. So now we write down two numbers which times together to give negative 6, but add together to give 5. So minus 6, positive 1, negative 1, 6, negative 3 and 2, negative 2 and 3. These add together to give minus 5. This adds together to give 5. Let's just check the others don't work. That's minus 1. That's positive 1. So therefore we can rewrite our quadratic as 2x squared minus this 1x plus 6x minus 3. So I have rewritten this original quadratic in a slightly different format. However, you will notice if you combine these together, this minus 1x plus 6x, you would actually be back at your original question. So although it looks different, they are definitely still equal. However, what that has allowed you to do now is split your quadratic down the middle. We do that as we need to factorise both parts separately, and this time we're going to factorise both parts into single brackets. So we're looking for the highest common factor of 2x squared and negative 1x. Well, here we're going to take out a factor of x. That leaves us with 2x minus 1. And this next one we're going to take out the highest common factor of 6x and negative 3. So here we're going to take out the factor of positive 3. That leaves us with 2x minus 1. At this point here, if your brackets don't match, that means you haven't took out the highest common factor. So it's a good way to check your answer is correct. So we now have x lots of this 2x minus 1 plus another 3 lots of this bracket 2x minus 1. So in total we have x plus 3 lots of this bracket 2x minus 1. So we took both of these numbers and put them inside this original bracket. You will now notice our quadratic is written in double brackets, and just like we did on question 1, we can solve each side. So we need to know when the left hand side is equal to 0, so x plus 3 is 0, that gives us our solution of x is minus 3, and when 2x minus 1 equals to 0. This one is slightly trickier. We need to add 1 to both sides to begin with, and then divide by 2. That gives us our two solutions for x. So question 4, it's very similar to the question above. Again, you have two options. You could solve this by using the quadratic formula. However, it's very likely to be on a non-calculator paper, so the best method here is to solve it by factorising. If you want to have a go at this, as it's very similar to the question above, please pause the video now. So again, we start with the same first step. We're timesing to make AC, which in this case is negative 90. And we're adding to make negative 1, this number in front of the x. So this one looks a bit trickier than before. We're trying to think of two numbers which times together to give negative 90, however, add together to have a difference of negative 1. So that tells you that these numbers must be very close together. If we think about our factors of 90, minus 9 times 10 gives you negative 90, and vice versa, negative 10 and 9 give you 90. These have a difference of 1. So let's see which one works. Negative 9 plus 10 is positive 1. Negative 10 plus 9 gives you negative 1. So now we rewrite our quadratic. So 6x squared minus 10x plus 9x minus 15 is equal to 0. Split our quadratic down the middle and factorise each side separately. So here we can take out a factor of 2x, that leaves you with 3x minus 5, and this next one we can take out a factor of 3, that leaves you with 3x minus 5 equals to 0. Again, here's a good way to check. Make sure that your brackets are the same. If not, you haven't factorised correctly or took out the highest common factor. Now we can piece these together. So we have 2x plus 3 lots of our bracket 3x minus 5. And now we need to solve each side. So 2x plus 3 equals to 0 gives you the solution negative 3 over 2. And 3x minus 5 equals to 0 gives you the solution 5 over 3. So here in question 5, it tells you to complete the table of values for the equation y equals x squared minus 2x. Now there's a few ways to do it. Some of you can just do it in your head. Some of you will prefer it if you draw out these extra columns. So x squared, we square our x. We have 4, 1, 0, 1, 4, 9 and 16. And then 2x, we just need to double our x value. So minus 4, minus 2, 0, 2, 4, 6 and 8. Now the equation tells you to do x squared subtract 2x. So we need to do 4 subtract negative 4, which gives us the answer of 8. Because we remember two negatives next to each other give you a positive. 1 subtract negative 2, well that gives you 3. 0 subtract 0 is 0. 1 subtract 2 is negative 1. 4 subtract 4 is 0. 9 subtract 6 is 3. 16 subtract 8 is 8. It's always a nice way just to double check that you get the answers the exam have given you. That tells you that your method is going to be correct. You will also notice with most quadratic questions you have repeated values, and that is because our quadratic graph is perfectly symmetrical. So now if we plot this graph, we know that it's going to give us this U-shape parabola, so that means it's going to be perfectly symmetrical. So when x is negative 2, y is 8, negative 1 is positive 3, 0, 0, 1, negative 1, 2, 0, 3, 3, and finally 4, 8. So now connect these together with a smooth curve. We do not use straight lines here. You'll then be left with your parabola drawn. So our final part of the question tells you to solve x squared minus 2x minus 2 is equal to 1. Well, we know on this graph we have got y is equal to x squared minus 2x. So I want to make this part C look like that equation. So I want to keep my x squared minus 2x by itself, and that means I need to get rid of this negative 2. So I need to add 2 to both sides. 1 plus 2 is 3. So now I've rearranged the equation to get x squared minus 2x is equal to 3. If this was equal to 0, my two roots would be where y equals to 0, in other words, where it crosses my x-axis. However, it's equal to 3. So what we do here is we draw a straight line going horizontally across at y equals to 3. Then, where these 2 points intersect, you are going to write down your two solutions. So where they intersect, if you draw a straight line down, you would get that first solution roughly at x equals negative 0.8, and your second solution where they intersect at 2.9. So here we have just solved that quadratic. Don't worry if yours are slightly different, because there is a little bit of leeway in the answers, because everyone could draw their curve slightly differently. You'll see mine isn't perfect because I don't go through every single point, but that's because I'm completing this on my tablet. So our last question, question 6. This is completing the square on a quadratic. The reason I know it's completing this square is because it's asked for it in this form, where it's given as a square bracket plus something at the end. So as soon as you see this part here, you need to think of completing the square. In order to complete the square, we follow a very simple method. We need to halve the coefficient in front of the x, so it becomes x minus 4, and then we square it. Then you need to subtract whatever number that is squared, and then we drag down whatever term we had at the end, which was this plus 6 in this case. So let's just recap those steps. We've halved the coefficient of x, so we've halved that negative 8 to get this negative 4. We then always subtract whatever that number is squared. I've put it in brackets so we don't get confused with our negatives. And then our last number just drags down to the end. That will then leave us, after we've simplified, with x minus 4 squared, subtract, negative 4 squared is positive 16, plus 6, negative 16 plus 6 is equal to negative 10. So then we have x minus 4 squared, subtract 10. So then if we read the question carefully, it wants to know what the value of p is. Well, p must be 4, as it's already got our negative sign in the bracket. And it wants to know what q is. Well, q must be negative 10. To finish off this question, to get your minimum point, so if we think about this graph, I'm just going to draw a random quadratic. We are looking for the minimum point of that graph. This is also known as the turning point, where your gradient turns from a negative to a positive. So we're trying to find this lowest point. You can get that from your completed the square form. So if we have a look at our completed the square form, we have x minus 4 squared minus 10. Our x value is when we make this bracket equal to 0. So if we make that bracket equal to 0, we have our x value. So x minus 4 equals to 0 tells you that x is 4, and then your y value is negative 10.